Okay, so question 12c, the last part of the last question. Yes, it's hard, which you would expect, as you'd expect for the last part, but it's not as bad as it looks. So we have, it's not as bad as part B, I think, anyway. We have g of x equals e to the mx. Consider the function h defined by h of x equals f of x times g of x. It is given that the x squared term in the Maclaurin series for h of x has a coefficient of 7/4. Find the possible values of m. Right. So what I hear there is Maclaurin series, and what I see is the multiplication of two Maclaurin series. Now, there's a few different methods in the mark scheme. I'm going to show you my preferred method. My preferred method, because I think that's kind of what they've been leading you to here anyway, is to get the Maclaurin series for f of x. That's pretty straightforward because we have all this stuff. Get the Maclaurin series for g of x. That's really easy because it's just the formula from the formula booklet. Multiply them out, get the coefficient, make it equal to 7/4, and find m. Sounds easy, yeah? Okay, so let's start with f of x. So to get the Maclaurin series of f of x, we have to go through this whole thing. So f of x is, let's just say 1 plus x to the half. F dash of x, we already got. It's a half 1 plus x to the minus a half. And then f dash dash of x is equal to minus a quarter 1 plus x to the minus 3/2. Right, we've already got these. F of 0, which we need for the Maclaurin series, is then 1 plus 0 to the power of a half, which is 1. F dash of 0 is just a half, because all of these are just going to become 1, because it's 1 plus 0 to any power is going to be 1. And f dash dash of 0 is equal to minus a quarter. Therefore, the Maclaurin series for f of x is, and I'm going to put approximately equal to, because I'm only going to put the first three terms. The reason being because we only care about the x squared term. So it's approximately equal to f0, which is 1, plus f dash of 0x, so plus a half x, plus f dash dash of 0, so that's actually minus a quarter over 2 factorial, so I'm going to actually make that minus 1 over 8, because I have to divide by 2 factorial, x squared. That's f of x to 3 terms. You can just put up to x squared if you like. Then g of x is approximately equal to, the Maclaurin series for e to the mx is just 1 plus x, so mx, plus mx squared, in a bracket, guys, be careful, over 2 factorial, which is 2. Again, up to x squared. Then h of x as a binomial, h of x as a multiple of these two expansions is going to equal, again, you could put approximately, but it's not a big deal, it's going to equal 1 plus a half x minus an 8th x squared times this, which is 1 plus mx plus, I'm going to write now m squared x squared over 2, close brackets. Now, we only care about the coefficient of x squared. So we're going to look for the coefficient of x squared. To get the coefficient of x squared, it's going to be, because if you multiplied out these two brackets, you do the first times the first, the first times the second, the first times the third, the second times the first, the second times the second, the second times the third, and the third times the first, the third times the second, the third times the third. I'm not going to multiply everything out. I'm just going to see which the terms I want. So it's the x squared term would be the 1 times this term. It would also be the half x times this term, because when you do your x times x, you get your x squared. And it would be this one times this term. So we're going to end up with 3 terms. So first I'll do 1 times this. Now I'm going to leave out the x squared because I'm just looking for the coefficient of x squared. So 1 times m squared over 2 is m squared over 2. A half x times mx, or a half times m, is just a half m, or m over 2. And an eighth x squared times 1 is just an eighth x squared, or again without the x squared, it's just minus an eighth. And it says in the question, the coefficient of the x squared term for the Maclaurin series of h of x is 7 over 4. So I'm going to equate it to, I'm going to equate this to 7 over 4. And now I just have a quadratic that I will solve. Best thing to do, guys, is multiply everything by 8 to get rid of all the fractions. So I'm going to have 8m squared. Sorry, I'll just do 4m squared because the 2 will cancel. 4m squared plus 4m minus 1, because the 8 cancels, equals 7. Subtract the 7, 4m squared plus 4m minus 8 equals 0. I will divide by 4. So I get m squared plus m minus 2 equals 0. Factorize this. It gives me m plus 2 times m minus 1 equals 0. M equals, or m plus 2 equals 0, or m minus 1 equals 0, m equals negative 2, or m equals 1. And that's it. That's the last question. I'll see you for paper 2.